Hello everybody. In this lesson, we're going to study displacement reactions, what they are and why they occur. What we need to know is what exactly is a displacement reaction. So a displacement reaction occurs when elements switch places in compounds. This type of reaction involves ions, which are electrically charged versions of atoms, and ionic compounds. These are compounds in which positive ions of a metal and the negative ions of a non-metal are held together by ionic bonds. Generally, a more reactive element replaces an element that is less reactive, and a less reactive element is set free from the compound. There are two types of replacement reactions. Behind displacement reactions is really very simple, but you do need to know your reactivity trends, particularly for groups 1, 2 and 7 to understand it. So group 1 are basically alkali metals, which are the most reactive, and group 2 are alkali earth metals, which have similar properties, are all shiny silvery white and are somewhat reactive. And group 7 are halogens, which are reactive non-metallic elements that form strongly acidic compounds when reacting with hydrogen. In order to remember your reactivity series, we can use a really simple mnemonic that is, please stop calling me a careless zebra, instead try learning how copper saves gold. The first letter in each of the words in the sentence represent the element that it stands for. So P for potassium, S for sodium, Cal for calcium, M for magnesium, A for aluminium, Ca for carbon, Z for zinc, I for iron, T for tin, L for lead, H for hydrogen, C for copper, S for silver, and then gold for gold. So like I said before, a replacement reaction occurs when elements switch places in compounds. In order to study this further, let's consider a very simple displacement. Think of common table salt, sodium chloride, which is an ionic compound. In molten form, sodium has donated one electron to chloride to form an ionic bond. So both ions have their completed octet to be stable. But then comes a rubidium atom, which is higher than sodium in the reactivity table and is able to donate its outer shell electron much more easily and attracts the chloride far more. So the chemical reaction happens. The ionic compound becomes rubidium chloride and poor old sodium is kicked out. It has been displaced. Metals often remain in their pure form after being displaced or replaced. This can actually be very useful, as some of the less reactive and easily displaceable metals are also the most precious ones, like platinum, gold and silver, and there can be value in displacing these from their ionic compounds or solutions. Displacement reactions are often best studied by solution chemistry. During the reaction, you get to see that the more reactive metal gradually disappears as it forms a solution, and the less reactive metals coats the surface of the more reactive metal. For example, magnesium is a more reactive metal than copper is. So when a piece of magnesium is dipped into blue copper sulfate solution, it fades as colorless magnesium sulfate solution forms, and the brown copper coats the surface of the magnesium. Magnesium powder is added to blue copper sulfate solution, and when stirred, they change into a colorless magnesium sulfate solution and copper powder. Here are the equations for the reaction. So when you add magnesium and copper sulfate, what you get is magnesium sulfate and copper. And if you do things the other way around, you would not see any reaction. If you put copper powder into magnesium sulfate solution, there would be no reaction, and this would be because copper is not reactive enough to displace magnesium from magnesium sulfate. Watching this, if you have any questions, you can email me.